Algebra final. Start with problem number 1 here. Use the 3 points to construct a triangle and give the length of each side of the triangle. Hopefully it's pretty clear how you need to connect up these points to make a triangle. There's only one way to do it. Just do every combination and we will get a triangle. All right, we need to find the lengths of every side. So that requires that we're going to go to these points and label them. This point here is 5, 3. This point down here is 6, -6. And then we can use the formula. I'll write out the formula, or you can think about just the Pythagorean theorem and constructing little right triangles that connect any two sides. All right, so the formula for distance is the square root of the difference in the x values, so x2 minus x1 squared, plus the distance in the y values, so y2 minus y1 squared. All right, let's see what we get here. We've got the square root of 6 minus 5 squared plus -6 minus 3 squared. That's going to become the square root of 1 squared plus -9 squared, the square root of 1 plus 81. So this length in here is the square root of 82. All right, use that same method to find the other ones, or you can construct little right triangles that connect any 2 points. I'm doing a bad job of this, but you just simply follow the grid lines. And then you can just count the boxes. So this is 3, this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now 3 squared plus 11 squared equals this length here squared. Sometimes we call that c squared. All right, use the 4 dots to construct a parallelogram and then state the midpoint of each length. So let's go ahead and construct us a parallelogram. There we go. Now we got to find the midpoint, so we need our midpoint formula. Essentially what we do is we average the x values, so you add them together, divide by 2, and we average the y values. And that should give you the midpoint of any two lines. So we'll do this point here at -6, +1. And this point here at 2, 7. We'll find their midpoint. So that's going to be -6 plus 2 over 2 and 1 plus 7 over 2. So let's see, this becomes -4 over 2, which becomes -2. And this becomes 8 over 2, which becomes 4. Let's check that that's actually on our line, -2, 4. It's right there. And yep, that looks like about the midpoint of that line segment. All right, construct an irregular pentagon and calculate the slope of each side. So connecting adjacent points to keep this an open shape. Don't want to be crossing up any lines here. All right, and now we just need our slope formula. So any slope m between 2 points is y2 minus y1 over x2 minus x1. This just directly calculates rise over run. I'll find the slope between this point here, that's -5, 1, and this point down here, that's -1, -3. Plug in our points, we get -3 minus 1 over -1 minus a -5. So -4 over, that becomes a +5, so +4. Which equals -1. So the slope in this segment here is -1. And that looks about right. We're going down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1 consistently. All right, and in problem number 4, we're going to write the equation of each line. So these ones in the middle, first we get a slope by just looking at the rise over run. We can construct a little slope triangle. We go up 1, right 3, so that gives us an m of 1/3. The pattern seems it's going up every 2, so this very first one is going to be y equals 1/3 x plus 10. Then we're going to have y equals 1/3 x plus 8, y equals 1/3 x plus 6, and so on. What we might notice is that we always have the same slope, and that makes sense because all of these lines are parallel and therefore should have the same slope. All right, let's see. Identify the center and radius of each, then sketch the graph. So the center, let me write out our generic formula for the equation of a circle. X minus h squared plus y minus k squared equals r squared. So we just look at the h and the k value for the center. The center should be at h comma k, but you ignore the minuses if there is one, and you add in a minus if there isn't one. So the center of this circle is going to be at -4 comma -1. All right, so we flip the sign on those. Now we go to -4 comma -1, we make a dot. This 9 here is r squared, so that means that if 9 equals r squared, we can just take the square root to find that our radius is 3. So around this circle we can go out 3 in every direction, and then connect those points with curved lines to make a circle. All right. This just gives you the center and the radius. You can plug that into the formula. Here we've got the circumference, so we need to know the formula that circumference equals 2 pi times the radius. And that way we can plug in 16 pi for our circumference. Divide both sides by 2 pi. Pi's cancel out on this side, and we get that 8 equals the radius. So now we can write down our formula now that we know the radius. X plus 10, remember flip the sign on that, squared, plus y plus 6 squared equals the radius squared, so 64. All right, with a point on the circle, you can just calculate the distance there. It's pretty easy to see that the radius here is just equal to 3. With the area, use the formula that the area is related to the radius by area equals pi r squared. So if we plug in a 5 pi on this side, equals pi r squared, divide both sides by pi, and then we get that 5 equals r squared. We're just going to stop there because r squared, we can just plug that into our formula for r squared. We don't have to figure out what r is and then square it for the formula. You're done. So we get x minus 16 squared plus y minus 8 squared equals r squared, which is just a 5. Okay. Ends of the diameter. Let's find the distance in between these. Doing distance formula, I'm just going to do sort of a shorthand. 8 squared plus the distance there is 14 squared. Take the square root. 8 squared plus 14 squared, and my calculator is 260. So the square root of 260 is the diameter. So the square root of 260 over 2 is the radius. We can simplify that. We can make that. Let's just wait till we square it, and then we'll square the top and the bottom, and then we'll simplify from there. All right. So also we need to do midpoint to find the center here. So average the x's, and we'll get a -4. Average the y's, let's see, 11 plus a -3 is 8, divided by 2 is a 4. So 4 comma 4 is the center. Now we plug it into our formula. X plus 4 squared plus y minus 4 squared equals, and we want to do this squared to get r squared. Well, that will cancel out that square root and turn this 2 into a 4. So I got 260 divided by 4 is 65 for this side here. All right, what if the center's at 8 comma -1 and it's tangent to the line x equals 4? Well, to get from the center at x equals 8 to the tangent line at x equals 4, the radius must be 4. because that's how you get from 8 to 4, and then you can go from there. All right, if this one's been translated 2 left and 1 down, well, we can translate left and right with this number. 2 left just means do a plus 2 here, so this becomes an x plus 3 squared, and then do an extra, or a minus 1 to that, so this becomes y plus 2 instead of y plus 3 squared equals 100. So it was being moved 5 to the right. 1 second. That should be a minus there. So it was being moved 5 to the right. Now it's only being moved 3 to the right. Let me double check that one. 12. X minus 3, x plus, or y plus 4. Okay. And now we just have a circle. We can just identify its center at 4, 1, and its radius of being 3, and then plug that into our formula. All right, let's keep going. We need to draw a graph with x-axis symmetry, and it's going to go through these 2 points. So I'll make it kind of swirl through there. Now, if it's symmetrical over the x-axis, any point x, y is going to become the point x, negative y. So it's going to flip over to this side. And then this point is going to flip over here because it's, wait, that's over the y-axis. Whoops. Over the x-axis. So it's going to flip down here. And this one's going to flip up here. And now we got to just make it symmetrical looking. There we go. That's over the x-axis. For the y-axis, any point x, y is going to become the point negative x, y. So let's put in a line that hits these 2 points. I would do that. Now I'm going to flip it over the y-axis. So this is what I accidentally did last time, comes over here. This point comes over here. And now we connect them up and we try and make it look somewhat symmetrical. Not amazing, but that is y-axis symmetry. Over the line y equals x, so here it can be helpful to dot in the line y equals x to show kind of where the plane of our mirror is going to be. Don't know how to make that go away. There we go. So with this, any point in the original graph x, y, it's going to flip to being y, x. So this point at 1, 4 is going to become 4, 1. Negative 4, negative 2 will become negative 2, negative 4. And if our graph did something like this, then its mirror image would do something like that. All right, and origin symmetry. So this is where it kind of gets rotated around. Any point x, y is going to become the point negative x, negative y. So this point 3, 4 becomes negative 3, negative 4. And so if we got some graph that looks like, give it some features like that. That's a little bit harder to do. Okay, so it's going to come in there, loop up, maybe this was too hard, something like that. That doesn't look quite right. Let's make it easier. Let's make the graph just do something like that. Okay. And then this point here got flipped around to there. So now this is going to come in along this line. Across there. It should look like this has been rotated 180 degrees. Not my best work, but that's approximately correct. All right, a constant graph. Constant graphs are just totally horizontal. They never change. They don't even have a slope. Cubic can turn twice. So 1, 2. So there's your constant, there's your cubic. Linear, straight, but does have a slope. Quadratic can turn once. And logarithmic has a vertical asymptote, and then it just sort of curves off to one side. So it's got like this vertical line here, it won't go past, and then it just kind of curves off and up. Rational has both a horizontal asymptote and a vertical asymptote, and it sort of lies flat to these straight lines by curving into the corners here. All right, square root, very similar to logarithmic, but it just starts at a point. So it's just like starts right there and then curves off. It's kind of a slightly different curve, but unlike the logarithmic, it doesn't shoot off to negative infinity, it just stops. In absolute value, those make V-shaped graphs. So that's an absolute value graph. It's not a very good one. Here, let's see. Absolute value graphs, they shape a vertex and then matching slopes on the opposite sides. There we go. Okay. Looks like we're getting a little bit into the next unit, so we'll take a break here to break it into part 2.